So good evening, everyone, again. Welcome to our webcast follow-up for week 2. So this is just a follow-up from our previous webcast. Normally, we will not be able to cover so much content in 1 week, which is why we have a back-to-back webcast. But due to the a lot of concepts were explained and we extended the webcast beyond an hour, we were able to complete all the topics last week. So based upon review of some of the assignments and some basic fundamentals needs to be considered and needs to be understood, I would like to give you some high-level overview. This will not only help with your course, but will also help in your day-to-day career if you are really into doing database core setup architecture concepts. I'll give you some of the basic fundamentals. Then I will walk you through some of the ER diagram concepts. Some of you are unable to grasp the topics. I'm hoping this will help you, because this will be a basic understanding for you to move forward as well. So first, let me know, are you all able to hear me well? Christian, my audio is clear?
Yes,
Christian?
we can hear you.
Yes, I can hear you.
Okay, just want to make sure. Last week we had audio problems. Okay, so I'm showing you in PowerPoint from one of the leading textbooks which we use for a different course. Okay, and I will share my PowerPoint and tell me if that is visible. If not, I have to share with a different method.
No,
Can you guys see it? Okay.
Yes.
Okay. So I'm going to put the phone on speaker, and if you cannot hear me, please let me know, because I have to operate and show you multiple screens and multiple windows. So I need 2 hands. And if you are not able to hear, please, okay? 1 second. Okay. So many of you have logged into ER Assistant on the virtual desktop. Okay, so this is how the screen looks. So every application or every industry has different terminologies. So in Oracle, an entity is called as a table. In some of the ERP applications or enterprise resource planning applications, the tables are called the records or tables. That's a different terminology is also used. So for the benefit of the class, let's say we are planning to create a student table and a course table. Okay, let me write the scenario so it will be easy for you. Okay. Okay. So I am writing very, very, very high level, very simple. Don't imagine this will be the level of requirements documents in your job. Normally, requirements documents will be 20 to 25 pages. Okay. Assume one of your business folks, and you're all technical people. Okay. For this 1 hour, you're all technical people. You're managers heading a technical department. Okay. Now, this is the requirements they give you, and you're giving it to your technical developer. Now, if you look into this business requirements, okay, so the first thing, I'm just giving you very, very quick and important shortcuts. So in the requirements, you have to look for nouns, okay? So this will become entities, straight, easy, okay? And the verbs will become relationships, okay? Rules will become the cardinality on the relationship. It's simple. Just remember these three, but don't go and tell anybody this is what my professor said, but I am giving you simple, easy way to do an entity relationship diagram, or how you can arrive or digest a requirements document. So assume this is what a requirements is given. So the nouns here are student and course, okay? Student and course. These will become entities, okay? Simple. Same, let's look at a student can enroll into 0 or more course. So that is the relationship. Student to course. That is the relationship. What are the cardinality? 0 or okay. So this is how you have to first dissect your information. Once you understand this, then you go into your ER diagram. So in the ER diagram, so first is new, then you click on entity, this will come. You click here, entity 1 is our student, okay? And attributes for student is student ID, primary key, number, I'm giving a length of 10, okay? And we need name. The character, I'm just giving 30, okay? Close, close, okay? Done. Student table is created. Now we want course table, okay? Course. For the course table, click on the attributes. In the attributes, a new attribute called course ID. Okay. Then we want description. I'm just getting this from our requirements document. Okay. Say 50. Close, close. Done. Okay. This is how entities are created. So, right, we have finished the noun part. Now, the relationship part. Okay. So, go here, click on relationship. So, always have a meaningful name. Okay. Student underscore course. It is relationship between a student and a course. Okay. Now, one student can take 0 or more courses. So, one student, if they take one course, see the relationship, how it shows. Okay. One student can take one course. But is this end of it? No. If you click this check diagram, you will get completeness error. The reason being, the relationship should be two-way. Okay. Let's click the relationship again. One student can have one course. Or then, if you have one, what type of a cardinality? Is it required or it's mandatory? So in our this thing, we just said cannot. Okay. this is once. Okay. Now we have to look at the other side of it. A course. A student can be optional in a course. Okay. This is how it's done. Now if you do the check diagram, there is zero consistency and zero completeness error. So in a simple English, each student can enroll in 0 or 1 course. If you want to change it to many, change it to many. Okay? And each course can have 0 or 1 student. If you want to do 1 or more, right. Okay. So this now if we verify, okay. Now let me come back to this PowerPoint. So this is how the basic symbols are there. So this square, the rectangle or square box is the entity. Now if it is underlined, it is the primary key. Normally in the ER assistant, the foreign keys are not mentioned. So don't worry about it. So the columns are called as attributes. Okay. And the relationship is here. And we normally give it a name. Here, in the PowerPoint, it is says has as the relationship. Now, okay. So what is cardinality notation? So you see here the single line. So one course will have 0 or many offering. Okay. Perpendicular line meaning one cardinality. And the symbols, what is outside of the entities on the relationship, those are called as Crowfoot notation. Okay. So, and each symbol has a different meaning. If it has Crowfoot like, it is a many type of relationship. 0 is 0 cardinality. If it is a perpendicular line, it is 1 cardinality, meaning 1 student. And if it has one more perpendicular line, that meaning it is a required. It cannot exist without a student. That is the meaning of the cardinality. So if you draw an ER diagram, you should draw the entity, you should illustrate the attributes, and you should identify which is a primary key of the attributes. Okay. So when you are creating the attributes, think about general concepts. Okay. So in the student and in the student name. Okay. In this table, if I create a student name as a primary key, what will happen? Can anybody say?
You'll get multiple students with the same name.
Can we get multiple students with the same name?
You can have multiple students enroll, but the database won't allow it.
Exactly, exactly. So, I don't know who was speaking. I cannot see the name because I'm looking at a different screen. So, you have to think about before creating a table or entity in your database, what is the generalized rules? How you want to architect your database? So here, take Prasanna. There could be multiple people with my name. John is a common name. Mary is a common name. So all these common names, multiple students would come with the same name. So we should allow them to enroll. If we have name as the primary key, duplication will not be allowed. And it will enforce the entity relationship concept there. So you should be thinking broad. So if I put student ID as a number, it's a uniqueness, and it will not allow you to duplicate. I cannot put 001 for Christian and 001 for Sabrina, 001 for other person. So it will stop. The uniqueness is not maintained. That's called as entity relationship, entity integrity. So that's how you have to think, how you have to identify which column can be a primary key. So now you should be clear on what columns can be a primary key. Now, the way the table, there's one other problem in this, I will explain. Let's go with the PowerPoint, okay? I'll only show you the high level which are important, which are made common mistakes, okay? So, normally there are 3 types of relationships. one-to-many, many-to-many, and one-to-one. So one student can take many courses. Many students can take many courses. One student can take one course. That is the three examples for these three different types of cardinalities. It all depends upon what are the rules given to you. Based upon the rules, you will establish the cardinality. Okay. Okay. Now, here is the situation right now. Okay. A student, 0 to many and 0 to many on both the sides, meaning both entities have many-to-many relationship with attributes. Okay. If you have many-to-many relationship, what does it mean? There should be a foreign key on the student table and there will be a foreign key on the offering table. In that situation, what happens is you cannot enter or you cannot insert values in either of the tables. It will be looping around. So if you run into many-to-many relationship, you have to convert it. Okay, how would you convert it? Okay, this is how you can convert. See here, the enrollment table is a associative entity. Don't worry about associative. There is an intermediate table. You need to have an intermediate table to convert many-to-many into two one-to-many type of relationship. If you do not have this type of conversion, you will run into issues, especially if you want to insert rows into the table. So you should definitely have this conversion. If you did not have this conversion, on the paper it looks good, but when you're converting into the DDL and DML, you will face issues. So in this case, let's go back. So student and course. So if this cannot work well in the database, now in order to convert this many-to-many relationship, you will have an intermediate table like enrollment. So a student can enroll into one or more course, and a course will have 0 or more enrollment, something like that. You need to have an intermediate table. Once you have an intermediate table, this many-to-many will be converted into one-to-many or one-to-one type of a relationship by adding a third table. If always remember, you cannot have many-to-many relationships in ER diagram. Any questions so far?
Do you want the diagram to also not have the many-to-many?
No, it should not.
Okay.
I'm just, because this is a 3.5 hours lecture, I'm just going to pick up what is important, okay? Don't worry about my breezing through. Relationship. Okay, so, and these are some other things which you need to understand. So don't create a self-identity or weak entity in the diagrams, meaning here you can say weak. Okay, so don't create entities like this. These are for certain reason, and for this course, don't do this type of weak entities. Weak entities means the entities cannot be on its own. It needs some supporting. The entity borrows a key from the past in order for it to exist. That is called as a weak entity. We'll not go towards those concepts. Those are very, very high level concepts which we go through in an entire course called DBST 651. We are not worried about this. In this course, we are making sure you understand the core concepts of SQL, ER diagram, how to create a simple structure, how to do data manipulation, and how to extract the data, and how to present the data using visualization. That is the core concepts here. Don't worry about all these things. So try to create a meaningful diagram, interpret the diagram thoroughly, and then make use of the diagram. That is what we have to understand here. So here, just understand the tables have to be created, good primary keys have to be selected, and try to avoid redundancy and try to avoid errors with relationships. That's what you have to think about with ER diagrams. Okay, any questions so far on the ER diagrams? Okay, now, so some of the other mistakes that are commonly happening, okay? When you write a script, and normally, and it is a good practice to write good comments with the whatever you're trying to write in the script. For instance, I have written a script. Let me, okay? So this is a script I have written for an order entry database, okay? So for this order entry database, first you have to put some comments on there, okay? What is this script? Why it is written? Who has written? And what made them to write this script, when it was written, and any version control. That has to be on the top of the script. Normally it is done. Then once you have given an overview of that, then next thing is, first is script background, okay? Then comments about commands, okay? For instance, drop writing. So why do you have drop tables? Please understand, you should not do this in your industry. You will not have drop commands in the industry. For the benefit of the course, for the benefit of the class, we have these drop commands. The reason for having these drop statements, you can execute the script multiple times. Okay, in the industry, no one will have permissions to drop. The reason here is what you have to say: drop table if the table exists. Meaning you are clearing the table if there is a table by that name, and then you are creating the table. Meaning you are starting with a clean slate. Then once you create the table, once you do the inserts, if you want to rerun the scripts, you have to drop the table and recreate the table. That's why we have the drop statements in the first. Then we create the table, then we do the insert statements. Okay, last webcast I told you, if there is no foreign key in the table, please assume that is a parent table. Okay, the reason to have this analogy in your mind, the parents come into the existence first, then the child comes into existence. In this example, I'm creating the product table. So after I create the product table, I am creating the employee table. Why I am creating the employee table next? Because this employee table is borrowing a key from another table. So that table has to exist. So whatever table which has a foreign key, that becomes a child table. Okay. Now, when you have to create the parent first, then you have to create the child. When you are dropping, you have to drop the child first, then drop the parent. Okay. See here, we are dropping the product at the end, but we are creating the product at number 1. The reason is, if you drop the parent, it will say a table rows are referencing, we cannot drop. The rows becomes orphan. So the child becomes orphan without a parent. That's the error it will tell you. So when you create the parent, then you create the child, and then you establish the foreign key relationship. When you drop the child first, then followed by the parent. This is the normal order for the class if you want to write the script and execute the script multiple times, because when you write the script, you really do not know whether the script is going to work or not. So, for instance, I do write here. So when you want to do a DDL, I'll say create table student. See, I'm using a powerful editor now. Okay, don't worry, it automatically puts the parenthesis. Okay, now I want student ID number 10, comma, name, character 30. Okay, then I will be writing the syntax for primary key and name of the primary key. So it's a syntax is there. So first, what is that? You will say constraint name, constraint type, and the constraint call. That's all. That becomes your primary key. So you will write the primary key. The same way for foreign key, it's the same constraint name, constraint type, references the primary key of which table is what you have to write for foreign key. There's no difference. Okay, it's a small difference. Here it is. Constraint name, constraint type. What is the column of the constraint? It references which table. So supervisor employee number references the employee table. That's all you have to think about. So this is how you have to structure when you're creating your scripts. Okay. Now there's one other thing I just want to
I think we lost audio.
No, I'm just thinking if I show you the model, it becomes I'm giving up my responses for your week 2 assignment. I'm trying to think how I should give you. Okay, so let's look back. Okay, now let's okay. So this will not have an issue. Now, when you create like this, right, now you have to think of the scenarios. So there are 3 scenarios you have to think. Okay, what are the 3 scenarios? So do an insert. You can just think in the mind itself. You don't need to write the statement. Okay, insert into the table. Okay, so these are called as checking for anomalies. Okay, if you can insert a row into the table, and if you can delete a row and you can update a row in the table without impacting the other rows in the table, that means you do not have an insertion nor deletion or an update anomaly in your table. When you don't have these 3 types of issues, then your ER diagram is a normalized ER diagram. Whenever you are creating an ER diagram, it should be normalized. These are the acid tests for checking whether your table diagram is correct or not. Okay, what I mean by this thing. For instance, when you're creating a specific, like you're going to a doctor office, right? When you're going to a doctor's place, say like for example, physical exam, okay, $200. Okay, let's say cleaning. I'm talking about a dentist. Okay, $50. Okay. Extraction. 100. Okay. Now, so let's say these are the different types of treatments, and these are the different types of the charges. Now, if you have this type of data in the table, imagine you're telling this, I can say, treatment charge. These are the two columns. And can you have a treatment as your primary key? Just say yes or no.
No, because you might get the same treatment multiple times or for multiple people.
No is correct, but I'm going to connect this to a patient table. You can have multiple treatments. The reason why it is no, right? For instance, if I want to change this physical exam to $300, the only way to change is you have to alter this. Okay? So that is not how you do it. You need to store the history of the transactions. These are called as the core setup information in your database. So you have to refer back. Oh my God, I charged Sabrina $200 last year, but now the physical exam is $300. How I charged her $200? Because if you want to change, you have updated it. That's not how you do. You insert a row into that specific table with the new charge. So how you have to do that? You have to have okay. If you do like this, let's say treatment ID is 001. Okay. So this is how you should. So now you want to increase the charge to 300, right? So what will happen? You can do this way. I'll tell you how you can do the same, okay? Okay. So how you can do this way is you have to have a combination key. Transaction ID with an effective date combination. It will allow you to insert the same row but with a different effective date. But this is a higher concept, but don't worry about this concept. Take only one key. So here you will have a different treatment ID, say 003, and you don't worry about effective date. You will have the treatment physical exam, and then you say 300. So you should be able to insert row but not destroy the information what is already in the table. So in the industry, these tables are called as core setup tables. So these are stored before you start your transactions in your organization. These transactions are dependent upon your core table. Simply you cannot. That's why for the assignments, whenever we are giving a scenario, think in a broader concept. Hey, what happens in an opera table? So we are asking to create opera attendance. How can think practicality? What is that we are asking? What is that is required? Oh, can I connect like this? What happens if I connect? What happens if I want to change? What happens if the attendee decides not to attend? All these things you have to think, and then you have to frame how you want to connect, what columns you have to connect, in what scenarios, and how you have to structure your cardinality. Okay, that's why I didn't want to show a live example. I'm giving an indirect example. So understand the core concepts and make sure you apply that for your assignments. Okay, any other questions? So any other thing I can explain, any other points I could give you pointers. This is the one thing which I've been seeing many of you have made some errors. I thought, okay, let me make sure people understand what is the importance of a cardinality, and when you connect tables, these are most important, okay? So once you understand this, look into the videos, look into the notes what we have posted, you should be having a smooth sail until week 6. Then we will have one more webcast for Tableau and Python. If there is a need, we will have a follow-up for Python. There will be a separate webcast. So that will take you to week 9 and week 10. Week 11 and week 12 will be some high-level presentations that you will be creating. So you will have thorough progression in the course. It's not like a bombarding it. But week 1 and week 2 will be a slow progression. The reason is people have to connect, make sure there is no issues with virtual desktop. Once all this is done, boom, it goes at 100 miles an hour. Okay? So those are the things I really wanted to explain, and I want to make sure you all understand what are the diagram concepts, what are the errors common people make, and how to avoid it. And last week, Deepa showed the relationship and how you join. So keep a very blind concept. If you want to join 2 tables, there should be 1 join condition. If you want to join 3 tables, there should be 2 join conditions. That's the most important one. If you don't have a join, it will kill the information what is coming out of the table. It's not the correct information. That's all. So once the joins and the rules are followed, you should be in a good shape to move on. Any questions? Anything I can explain? I'm unmuting everybody, please. If there's a background, you can mute yourself. Anything you want me to explain? Are you clear? Can you give me some feedback? Is this webcast helping you all? I know it is in the middle of the day, but okay. So please email us what you like and what you don't like, what you would like to see in the future webcast. We'll definitely accommodate that. And second thing, make use of your faculty and your faculty assistant. They're really helpful. The faculty assistants are really talented individuals. They work in the industry, so they will be able to provide you guidance. And in spite of that, you're always welcome to reach the faculty. They are there to help you and make you successful. Okay? So if there are no questions, I'll post this recording. Make sure you understand these concepts. Go through all the video recordings, all the notes that we have posted for each of the week, and read the specific links that are available. And then if you still have questions, please post the questions in the class. One of us will be reaching out to you and able to post our response and make sure you understand it. Okay? That's all I have. Thanks, everyone. Thanks for joining. If you have any questions, let me know. I will wait for the next 5 minutes And if there is nothing, then I will close the meeting.
Thank you.